Second example of block diagram reduce technique. The summing point is the transfer function is g1. Those another summing point. The transfer function is g2. The transfer function is g3. And the feedback element is h2. It's connected here. The another feedback element is h1, summing point connected to feedback element. The input is r plus minus the output is c, and the summing point is minus put plus. This is a block diagram. The here the two feedback element h1 and another is h2. The feedback path is connected between the transfer function g2 and g3. G2 and G3, and another summing point is connected between G1 and G2. That's the first step. We'll see that it is called the takeoff point. When I will connect the takeoff point, or takeoff point is forwarded after the transfer function G3, then the block diagram reduction technique will be easy. Now we'll see the step 1. If the takeoff point is here connected, then the block diagram reduction technique is very difficult. At first we'll see the block diagram will easy. When it is easy, then the takeoff point will forwarded after is connected is G3. The summing point, the transfer function is G1. The summing point and the G2 and G3. The R is input, C output. Another feedback element is H2 is connected to here. Another is here. Then another transfer, so feedback element is connected between G2 and G3. Minus, plus, plus, minus. The takeoff point is forward here. The takeoff point will move here. The takeoff point is connected after the transfer function G3. When the takeoff point is forwarded, then the feedback element is divided by G3. We will see the step 2. Now step 2. The R is input, transfer function is G1. The summing point G2. Another point is G3. The H2 is feedback element is connected to here. the feedback element is divided by transfer function g3. Here will be connected after forward the takeoff point plus minus h1 by g3 by 3. That first will g2 and g3 is connected in series. G2 and g3 is connected series. Then the result will be step 3. So function is g1 and g2 and g3 here multiply. The summing point, the g2 into g3 and multiply because they are connected in series. Connected to here, it is here. This is plus r, it is plus h1 by g3 connected to here, here. Here the feedback element is h2 and g2 and g3 is equal to total value of gs. That means it is the next step, step 4 here, the gs by 1 plus gs into hs. Here the gs equal to g2 into g3. The summing point, the g1 here the gs is equal to g2 into g3 by 1 plus gs equal to, we know that g2 g3. I told you the in step 3 g2 and g3 to h2 h2 h1 by g3 connected here, it is connected is r input and c output is plus minus. There g1 and this function is connected series. Then g1 is multiply g2 into g3 by 1 plus g2 g3 into h2. And the result, the summing point is the g1 into g2 to g3 by 1 plus g2 g3 to h2. I connected the h1 by g3 plus minus r. Step 3 is step 4 is step 5. The h1 by g3 is total, it is the feedback element. It is a feedback element is, and it is a total transfer function. That means we know that the formula gs by 1 plus gs hs, gs is equal to it is and hs is equal to total function it is. Then the step 6, step 6, G1, G2 and G3 by 1 plus G2, G3 to H2 by 1 plus GS, G1, G2, G3 by G2 to G3 plus H2 into H1 G3. G3 R is input, C is a output. The total value equal to GS. So 1 plus is equal to GS. H1 by G3 is equal to HS. Therefore, the transfer function C by R equal to G1, G2, G3, G1, G2, G3 by 1 plus G2, G3, H2 divided by 1 plus G1, G2, G3 by 1 plus G2, G3, H2 into H1 by G3, right? Or the next step C by R equal to G1, G2, G3 divided by 1 plus G2, G3 H2 into 1 plus G2, G3 H2 divided by 1 plus G2, G3 H2 plus G1, G2 H1. The final step or final result equal to G1, G2 to G3 by 1 plus G2, G3 H2 plus G1, G2 into H1. This is the final result.